sum to n terms of geometric progression, or in other words GP. So here we are going to find out a formula for sum to n terms of geometric progression, that is in abbreviation, that is GP. So here we are going to assume the first term of the geometric progression as A and the common ratio as R. Then the general form of a geometric progression will be of A, AR, AR square, AR cube, dash dash dash. Then now nth term will be of AR to the power of n minus 1. So here, based upon this, we are going to find out the sum of n terms denoted by means of S of n in an advanced level. So here, since we are going to find out a formula for sum of n terms of the geometric progression, that is GP. So first of all, we are going to assume. So here, let A be the first term of geometric progression and small r be the common ratio. Then now, and similarly sum of, so here we are going to suppose, so here let sum of n terms of geometric progression be, since it is sum of the n terms, so I am going to write it as the capital S, sum of the n terms. So here by means of S of n or Sn. But here we know that the gen form or the general form of the geometric progression is of A, AR, AR cube and so on. AR to the power of n minus 1 will be the nth term. So here we know that the general form or the gen form of geometric progression is given by the terms such as A is the first term and the second term will be of AR, and the next consecutive term of AR is of AR square. Then now next term will be of AR to the power of 3, so which is the fourth term. So here AR to the power of 0 is the first term and AR to the power of 1 is the second term, and the third term is of AR to the power of 1 less, that is 3 minus 1 is of 2. So your fourth term, so here T4, in order to get T4, so that is AR to the power of, that is fourth term, so 4 minus 1 equals to 3, AR to the power of 3. So similarly AR to the power of 4 will be the fifth term and so on. In order to write the nth term, so here we have to write it as AR to the power of, so here preceding to this nth term, so here we will be getting it as T of n minus 1 term, so here T of n minus 1 term will be of, so here n minus 1 but minus 1, so here comma, so here in order to write the nth term, say AR to the power of 1 less than this order, that is n, so here it will be of n minus 1, so here we will be getting it as n minus 1 of minus 1, so minus of minus is plus, we have to add up 1 plus 1 is of 2, that is n minus 2. So here this is the gen form of a geometric progression, so we are going to write it as that is, so that implies the gen form is of A, AR, AR square, AR cube and so on, comma, AR to the power of n minus 2 is the T of n minus 1, that is n minus 1th term, then AR to the power of n minus 1 is the nth term. So here first term is of A, the second term is of AR, the third term is of AR square, then the fourth term is of AR cube, then nth term will be of AR to the power of n minus 1. So here 1 less than this, the preceding term will be of T n minus 1, that is the n minus 1th term. But here let us write the sum of all these terms. So in order to find out the sum of n terms, so we have to sum up, that is, we have to add up all these terms, sum of n terms of geometric progression. So here these are the terms of geometric progression. So here we are going to sum up, that is, we are going to add up all these n terms of this geometric progression. Then we have since we are going to find out the sum of n terms, so here we have assumed by means of the sum of n terms as S of n. So instead sum of n terms we can write it by means of S of n. S of n is equals to, we have to add up all these terms. The first term is of A plus the second term is of AR plus third term is of AR square plus fourth term is of AR cube plus and so on, plus n minus 1th term will be of AR to the power of n minus 2 plus nth term is of AR to the power of n minus 1. Let us write this as the first equation. Then now, so here I am going to multiply either side, that is both sides by means of the common ratio, that is R. So here the next step will be of, by multiplying both sides of this equation by means of the small r, that is the common ratio. So here we can write it as r as the common ratio. Then now the next logical step will be of, since we are going to multiply both sides, so Sn, so here S of n, that is sum of n terms, must be multiplied by means of r. So here I have multiplied by means of the r on the left hand side. Similarly I have to multiply, so total right hand side by means of r, so r multiplied by means of r dot. So here r is multiplied with, so this entire, so here a plus ar square plus ar to the power of 3 plus dash dash. Last but one term is of ar to the power of n minus 2, which is the t n minus 1, that is n minus 1 term. So here plus last term is of ar to the power of n minus 1, that is nth term. So bracket close. So here we have to multiply each and every term, n terms must be multiplied by means of this r. So now the next logical step will be of, so here r into Sn, that is rsn, r dot Sn is equals to r into a is ar, so r ra. So here a into r is of ar plus a into r. So here r to the power of 1 and r to the power of 1, r to the power of 2 as per the product rule. R into r is of r square. So here a r square plus a r square, it is of order of 2. So here the exponent is of 2, degrees of 2. So here one more degree will be added. So here we are going to multiply r to the power of 1. So one degree will be increased by means of 1, because here r to the power of 1. So it will be of, the third term will be of r to the power of, instead of 2 it will be of 3, because we are adding up, so r to the power of 1 also in this. So here plus ar cube into r, it will be of ar to the power of 4 plus dash dash. Then now plus ar to the power of n minus 1, n minus 2 written as it is, but it must be multiplied with this r, plus ar to the power of n minus 1 also must be multiplied with this r again. So in this manner I have multiplied each and every term by means of r. Now the next logical step will be of, so here r into Sn, so I can write it as r into Sn, so equals to, then now, so right side will be of ar plus ar square plus ar to the power of 3 plus ar to the power of 4 plus dash dash. So here r raised to the power of 1 and r raised to the power of n minus 2, there is of into symbol in between. The bases are equal here, r and r. Here also the bases are equal, r and r. Here also the exponent is of 1. Bases are equal and into in between it is the form of a power m into a power n. So here a power m plus n, that is exponents must be added up. So here plus a written as it is, r to the power of, base is r, common base, that is r is written as it is. So here these two exponents must be added up. So here n minus 2 plus this exponent, that is 1, plus a. So similarly bases are equal, here also the product rule is applied, that is a power m into a power n equals to a power m plus n. So here basis of r, that is r to the power of n minus 1, then now this 1 must be added up. So here sum of these two exponents. So here we can write it as, here directly we can cancel minus 1 and plus 1, they will be gets cancelled, so only r to the power of n is left over in the last term. Whereas here when we simplify further, n, these two are of common terms or similar terms or the like terms, so minus 2 and plus 1 are the constants. So here minus into plus is of minus, let us subtract 2 minus 1 is of 1, 2 is greater, so its sign will be minus, so we will be getting here n minus 1. The next logical step will be of r into Sn, r into Sn is equals to, first term is of ar plus ar square plus ar cube plus ar to the power of 4 plus dash dash. Then now here we will be getting the last but one term, that is n minus 1 term as ar to the power of n minus 1 plus last term is of ar to the power of n as per the previous logical step. Then now let us suppose this as the second equation. From 1 minus 2 equations, from first equation we are going to subtract, so it is of minus symbol from 1 minus 2, so this is of minus from 1 minus 2. So first equation is of, so s of n is equals to, so here the first equation is of, so s of n is equals to a plus ar plus ar square plus ar cube dash dash ar to the power of n minus 2 ar to the power of n minus 1. So it is of a plus ar plus ar square plus ar cube plus ar to the power of 4 plus dash dash plus ar to the power of n minus 2 plus ar to the power of n minus 1 is the nth term. So this is of the first equation. So here the second equation is of r into Sn. So here r into s of n, here the coefficient of this Sn will be of 1 here, here the Sn's coefficient will be of r. So here that equals to, the first term is of ar in the r into Sn equals to, first term is of ar then now First term is of AR, then the second term is of AR square plus AR square, then the third term is of AR cube, fourth term is of AR to the power of 4 plus dash dash AR to the power of n minus 1 plus AR to the power of n minus 1 plus AR to the power of n, which is nothing but the second equation. Then now, so here let us subtract. Since we are going to subtract the second equation from the first equation, the second equation signs will be, each and every term signs will be changed. So here it is of positive actually, so here it becomes the negative. So it's of positive, the new sign will be assessed as the negative, plus as minus, then now plus as minus, plus as minus. Similarly here plus as minus, then now here plus as minus. And the AR to the power of n, AR to the power of n minus 1, and before this term, so that is the, so term will be of plus AR to the power of, so here n minus 1, then this will be of n minus 2. Then now, so here instead of plus it will become minus sign. So since we are subtracting, so here plus AR and here new sign minus AR will be gets cancelled. Similarly, plus AR square minus AR square will be gets cancelled. Plus AR cube minus AR cube will be gets cancelled. AR to the power of 4 of positive, AR to the power of 4 of negative will be cancelled. AR to the power of n minus 2 is of positive, AR to the power of n minus 2 is of negative. Then now AR to the power of n minus 1 is of positive and AR to the power of n minus 1 is of negative, and this is of positive. Then now here just minus AR to the power of n is left over, and here only just A is left over. So here in this manner we got 1 into Sn, 1 into Sn, new sign is of minus R into Sn. So R into Sn, then that is equals to A. So here A, then now last term, each and every term is gets cancelled, then now only plus is assessed as minus sign here. So minus of AR to the power of n is left over, minus AR to the power of n. But so here the coefficient of R to the power of n is of A, here A's coefficient will be of 1 here. Then now here I want to take Sn, Sn is common in both the terms, so I want to take Sn as common. When Sn is taken out as common, just 1 is left over within the bracket, minus when Sn is taken out as common, just R is left over within the bracket. That is equals to, here also I want to take A as common. When A is taken out as common, just 1 is left over, minus A taken out, so just R to the power of n is left over. In order to find out, so this Sn, that is sum of n terms, so I have to, because there is of into symbol in between, so into 1 minus R I have to transpose over to the right hand side. Then now, so here into, that is multiplication becomes division on the other hand. Then now that equals to A into 1 minus R to the power of n divided by 1 minus R will be coming in the denominator's place. So here this we got, I say, by transposing the left hand side term to the right hand side. So here I wrote this logical step based upon this reason, that is by transposing LHS term over to RHS. Then now, so here R to the power of n value is less because this is subtracted from 1, that is R is less than 1. So similarly R is subtracted from 1, that is 1 is greater and R is lesser. So here, so R is less than this 1. So here this is applicable only when R value is less than 1. So in this manner we got, so sum of n terms when R is less than 1 equals to A into 1 minus R to the power of n by 1 minus R. So here we can write it as, then hence we have sum of n terms is given by means of the formula A into 1 minus R to the power of n overall divided by 1 minus R is applicable when R is less than 1. So here it is applied only when R is less than 1. Then now similarly, so here similarly this is the notation or the symbolic notation of similarly, we can write the S of n formula sum of n terms is equals to, so here the condition is when R is greater than 1, when R is lesser it takes the second place and 1 takes the first place, that is 1 minus R. If R is greater, then R will come in the first place and 1 will take the second place, that is R minus 1. Then if it is of R minus 1, so here then R will be greater than 1. So here we will be getting it as A into R to the power of n minus 1, R to the power of n, then here minus 1, just changing the signs of these two, positive will become minus negative and negative of R to the power of n becomes here positive, divided by 1 minus R as R minus 1. So here R is positive now. So here since it is positive, this is greater, 1 is negative, this is lesser. So R is greater since it is positive, so R is greater than 1. So we can apply this formula when R value is, that is common ratio is greater than 1. So in this manner, so we have deduced the sum of n terms as A into 1 minus R to the power of n overall divided by 1 minus R when R is less than 1. Then the second case is of A, sum of n terms is equals to A into R to the power of n minus 1 by R minus 1 when R is greater than 1.